For lesson 2.8, we'll be multiplying 3-digit numbers by 1-digit numbers. This is very similar to how we multiply 2-digit numbers by 1-digit numbers. Let's take a look. In today's lesson, they want us to compare a 2-digit and a 3-digit number multiplied by a 1-digit number. So the first thing I'm going to do is write this vertically. That means one number on top of the other number. So I have 39 times 7. I begin with 9 times 7, and 9 times 7 is 63. I carry my 6, and I write the 3 underneath 9 and 7. The next step is 7 times 3, which is 21. And then I add the 6 that's on top. So 21 plus 6 is 27. Now looking at our 3-digit number, 439, I multiply that by 7, and I'm also going to write this vertically, 439 on top and 7 on the bottom. I start with 9 times 7, or 7 times 9. I carry the 6. Then I do 7 times 3, which is 21, plus 6, 27. I carry the 2, and the 7 is here in the tens place. Then I do 7 times 4. 7 times 4 is 28, plus 2 is 30. So how are these equations the same? How are they different? Well, they both are multiplied by 7, and they both have 3 tens and 9 ones. They're different because this one has 4 hundreds. So I know my number is going to be larger. But I did multiply it using the same pattern. I start here, and then I move outwards. Or you could say I start with the ones, then the tens, then the hundreds, and so forth. I see here they're asking us, which strategy do you use most often? So the strategy I used here is the standard algorithm. So it's the way that a lot of people multiply 2 and 3 and more digit numbers. But maybe you like to use a different strategy, like the partial products strategy, where you get the larger number and you use the expanded form to figure out how you're going to multiply and then add in order to get your product or your final answer. On the next page, in the try it section, they want you to do an estimate first, and then you're going to check if your answer is reasonable. In order for you to do an estimate, you have to round. So you're going to take the larger number, in this case 123. You're going to round to the largest place value, in this case the hundreds. You look next door, 4 or less, let it rest, which means the number that you underline, or the digit you underline, you leave it alone, and everything else you will make into 0. So 123, we're rounding that to 100. So now that we rounded 123 to 100, we need to find the estimate by multiplying 5 times 100. 5 times 100 equals 500. So now let's find the exact answer. 5 times 3 is 15. Carry the 1. 5 times 2 is 10. Plus 1, 11. Carry the 1. 5 times 1 is 5. Plus 1, 6. And then they ask me, is it reasonable? 500 and 650. I would say it's a reasonable estimate. For your test, you do not have to find an estimate and then the exact answer and then state if it was reasonable. You will have to find estimates, but they will ask you that separately. Estimates, and you need to estimate what two numbers of the product of a multiplication problem is. What two numbers the product will fall between. If you want more practice with estimating the product, you can look at section 2.4. So as we move along to number 2, I'm going to rewrite this here to make it larger. 907 times 3. Again, we always start ones place, tens place, hundreds place. 7 times 3 is 21. 3 times 0 is 0. And now you add 2. So 0 plus 2 is 2. And then 3 times 9 is 27. So my exact answer, or my exact product, which is the answer of a multiplication question, is 2,721. Number 16 reads, a roller coaster is twice as tall as a Ferris wheel that is 228 feet tall. How tall is the roller coaster? A roller coaster is twice as tall. That's 2 times as tall as a Ferris wheel, which is 228 feet tall. So I know I'm going to need to multiply that by 2. 8 times 2 is 16. 2 times 2 is 4, plus 1 is 5. And 2 times 2 is 4. So it is 456 feet tall. For number 17, how can you estimate the number of digits in the product of 7 and 848? Well, if I round 848 to 800, I know that 7 times 800 is going to be 5,600. So I see right here that the estimate has 4 digits. So I'm going to also make an estimate, or an educated guess, that the exact answer will also have 4 digits. The height of 2 buildings in Miami are shown in the table. Well, let's see, I have the Pinnacle Park building and the Miami Tower. I have both their heights. Infinity at Brickell, that's this one, is also a building in Miami that is 5 times as tall as Pinnacle Park. Which building is the tallest? 5 times as tall. Sounds like I'm going to multiply. So to find the height of the Infinity at Brickell, it tells me in the word problem that it is 5 times as tall as Pinnacle Park. Pinnacle Park is 126, and I'm going to multiply that by 5. I see that they did that here for me. So 6 times 5 is 30. 5 times 2 is 10. Plus 3 is 13. Carry the 1. 5 times 1 is 5. Plus 1 is 6. So Infinity at Brickell is 630 feet tall. So let me see. The question they're asking me is, which is the tallest? Well, it's Infinity at Brickell, and it's only taller by 5 feet. Let's look at number 19. A principal has $2,000 to spend on updating some of your school's tablets. She buys 4 tablets that each cost $299. How much money does the principal have left? This is a multi-step problem. I have to do several steps before I can find my answer. So I know the principal has $2,000 to spend, okay? So she goes to the store and she buys 4 tablets, and each of those cost $399. I wonder what the total was at the register. Let me figure that out. $299 times 4, because she bought 4 tablets. 9 times 4, 36. I carry the 3. I put the 6 down here. 9 times 4 again, 36. Plus 3, 39. 4 times 2 is 8. And 8 plus 3 is 8, 9, 10, 11. So it looks like this principal spent $1,196 at the store. The question says, how much money does the principal have left? Which means I have to subtract. I know, I can imagine the story. At the register, they're scanning the 4 tablets. The total is $1,196, ma'am, and she pays $2,000. Well, I know she's going to receive change, which is how much money she has left. So I have $2,000 minus the total cost of the tablets. And now I need to find my answer. Okay, I can do this. I can subtract. Oh, hold on. 0 minus 6, I can't do that. So I'm going to borrow from next door. I can't do that because there's a 0 there. So I'm going to go next door. Oh, I can't do that because there's a 0 there. So I have to go next door. Finally, I can borrow. That becomes a 1. This one becomes a 10. And now the one next door can borrow. Oh, okay, but now I have to take one away. Okay, it's a 10. Oh, we need to borrow. Okay, so I borrow 1. And finally, I have enough to take away 10 minus 6, which is 4. And then 9 minus 9 is 0. 9 minus 1 is 8. And 1 minus 1 is 0. So I see here she has $804 left. Not bad. She could even buy another tablet if she wanted to. Practice a little bit more the steps we take to multiply a 3-digit number by a 1-digit number. Remember, if you're not practicing your multiplication facts, you're going to have a hard time solving these problems, because even if you know the steps, you're not going to know the correct answer. You'll be working with incorrect numbers. So in the end, it'll still be wrong. Make sure you practice your multiplication facts. 8 times 7, we start here in the ones place, then we multiply the tens place, then the hundreds place. So 8 times 7 is 56. Carry the 5 and write the 6 underneath. Now we do 8 times 2. 8 times 2 is 16, plus 5 is 21. And now in the hundreds place, 8 times 5 is 40, plus 2, 42. Our answer is 4,216. On your test, you can use whatever strategy you want to multiply. This is the strategy using partial products. Now I'm going to multiply each of those numbers by 8. And at the end, I'm going to add them all together. So the very first one I'm going to do is, well, I could start with the 500, but I'm going to follow this pattern of ones, tens, hundreds. So I will do 8 times 7, that's this one over here, and that equals 56. Then I will go to my tens. So 8 times 10, 8 times 20, I'm sorry. And I know 8 times 2 is 16, plus a 0, that's 160. And last, I have 8 times 500. 8 times 5 is 40, and then I add 2 zeros. There's a 40, and there are my 2 zeros. And like I said, I need to now add all of those numbers. So 6 plus 0 is 6. 6 and 5, 11. 1 plus 1 is 2. And 4 plus nothing is 4. So my answer is 4,216. I found the same answer. I just used a different multiplication strategy. Okay, let's solve 603 times 4. I start with 3 and 4. 3 times 4 is 12. Then 4 times 0. 4 times 0 is 0. Plus 1 is 1. And 6 times 4, or 4 times 6, is 24. This gives me 2,412.